let's talk IP addresses. They make the internet work, and that's why pretty much everyone in your home has an IP address. And we're talking about phones, watches, light bulbs, TVs, etc. But what is an IP address and what makes it work? So let's talk about that today. In fact, this is the first episode in a series that I will name Get Better at Subnetting. And in this series, we're going to start with what's an IP address, and by the end, you'll have gained subnetting skills on par with professional network engineers. And in any case, you might know or might not know IP addressing and subnetting, but this is a skill needed for everything in networking, hacking, security, cloud, and it's involving an IP address and a subnet. By the way, this is a series that will also help you better understand IP networks and subnetting if you will ever consider a CCNA certification. So with no further ado, let's get started. So what is an IP address? If you look at the definition, you can find it on the internet. It's a internet protocol address, and it's a unique numerical identifier assigned to every device connected to the internet that will allow it to communicate also over the network. Network can mean your internal network, right? And it serves two main functions. One is to identify the host, and the second is to provide its location within the network. That's more to enable the establishment of a path to that host, like communicating, right? So you are used to navigate the internet, and let's say you want to go to Amazon, and you're gonna type Amazon.com, but in actuality, that address is actually, if I can spell, yeah, this URL or web address, it's actually a translation from an IP address, and that goes pretty much with everything else, right? So that's that. Now, when you're talking about IPs, there are two types of IPs, and one is IPv4, and the second is IPv6. It's a more complicated, but we will get to a future episode where we will explain a little bit about IPv6 and why we need IPv6. So IPv4 obviously will give you an IP. This is an IP that you can find if you're using Windows, right? You can go to CMD, and in CMD you can type in ipconfig, and that will give you the IPv4 address. So mine is 192.168.2.56. I'm going to get a subnet mask and a default gateway. But this is the IP that my client or my host is using, my PC actually, right? That's why I put it over here. So as you can see, it's a string of numbers that are separated by a dot, and each group of numbers represents an octet. We're going to explain a little bit more about it later on. So they are, if you look at them simply, they are like phone numbers, but not really phone numbers, right? Because you already have phone numbers on your phone, and you also have an IP on your phone. So let's say when your TV wants to send a message to your Apple Watch to let him know that there's some offers on Amazon, he can actually communicate that information because they are on the same network. So as my PC has this IP address, then the other devices will have different IP addresses, but the first three, as you can see, will stay the same. So only the last octet will change. So I have for my phone 131, I have for another PC a 200, I have for my printer 89, and I have for a laptop a 45. And those IPs are given out by the router. This can be your ISP router, and I'm pretty much sure that everybody has that router at home. And to be honest, this private IP, the 192.168.2, I can assure you that in 90% of the cases, you might have the same private IP given out by your router. Maybe you would have a .1 or maybe a .5 or .10, but regardless, this is how the router gives out the IP through the DHCP server, right? You can manually assign IPs or you can let your router hand out those IPs. So let's say you want to check if your IP is assigned by DHCP or it's a static IP. Well, you can pretty simple right click on your network and internet settings, and then if you're connected with a cable, with the Ethernet cable, you can click on Ethernet, and you can see that the IP assignment it's automatic through DHCP. So DHCP assign us with this IP address. Now you can choose to leave it as it is, and every now and then, depending on the settings of your router, they will be renewed. So you're gonna get a different lease of a different IP, or you can make this one your static IP. So how you can do that is, well, you can click edit, go to manual, select IPv4, and then you can put the address here. So it was 192.168.2. I'm typing. So .2 dot what it was, 50 something, 58. I didn't even pay attention. Now subnet mask is by default 255.255.255.0. Now this little fellow will become very important later on, because that's what will decide the network itself. So here the gateway will always be, in my case, or maybe in your case as well, if you have the same private IP .1, and then I'm gonna leave this. Well, actually it might ask, so let's do a Google DNS, and then let's do a Cloudflare DNS just for this example. I forgot the dot. And now we have the manual IP address. What that means is that our IP will never change. So if, let's say, I have other devices on the network that are getting their IPs through my router, and those are handed out by DHCP, they're gonna get renewed every now and then. My IP will stay always the one that I just inputted, because I did it manual. So mine is a static IP right now. Right, with that out of the way, we're gonna leave it as it is for now. And we can go back to our examples. Let's go to the next slide. So again, we have, so it was 56, not 58. Maybe I want to change that. I didn't pay attention, my bad. Okay, that's cool. And if I do again an IP config, I'm gonna get the same result. But this time I know for a fact that my IP is static because it's manual. Right, with that out of the way, let's go to the next slide. And here we have our IPv4 address, and the range of each octet is from 0 to 255. So this is one octet, and this is the range for the first one. This is the second octet. This is the range. Third and fourth is the same range, right? So with that, we can proceed to the next step. As I mentioned before, we have our IP, and then the range, as explained before, it was from 0 to 255. But now the subnet mask will help us um, separate which of the octets will always change. So as you can see here, the first octet, it's a 255. Second is 255. Third is 255. If we look at the subnet mask here, we get the same thing, right? Now, the only thing that will change will be the last one, and that will be the host, right? And again, I forgot to put the dots, but each octet is separated by a dot. Okay, we're gonna move to the next one, and the next portion will explain why this range, this subnet, is important. Because when you have 255, it will lock in place the first octet. The same goes for the second, the same goes for the third. And the three first octets are called the network portion, while the last one that has a zero, it's the host. So this one can be anything from 0 to 255. Okay, which means that this is how many IPs you're gonna get on your private network at home or at work or wherever you have it deployed. While everything is hopefully very clear so far, we need to understand that all those IPs will be able to communicate within the network, right? But what happens if we want to connect outside the network? Now we have a little friend here, which is called a default gateway. And this default gateway will allow our hosts to communicate outside the network. For instance, you want to access Google, Netflix, Amazon, what have you. This is the address that will actually send the traffic over. All right. And to put it simply, your router is the default gateway, and the default gateway will be always this. Well, dot one, depending on the IP that you have. It could be 192.168.1, and then it's dot one, or you can have 192.168.10.1. That will be the default gateway. Obviously, in 90% of the cases, you're going to have something similar to what I have, but the dot one will always represent the gateway or the IP of the router. All right. And when you're talking about how many addresses you can get in this range, we already explained. So if you count the 0 to 255 are 256. But actually, I'm going to try to give you a small exercise. Think about a real world application. While we already discussed that one IP belongs to the router, which is the dot one, right? And that will leave us with less addresses. But because you have other IPs that are reserved, okay, let's find out what those IPs are. So let's remove this for a second. Now we have the network address that is reserved. You cannot use this one, 192.168.2.0. Then you have the broadcast address, 192.168.2.255, which if you communicate with this address or you send data to this address, it will broadcast that data all over your network. And as I mentioned before, the dot one represents the router IP address. So we are left with 253 usable IPs within that private network, right? So if we look at our example here, we know that we can choose anything between 192.168.2.2 up to 196 168.2.25 254. Okay, so that will leave us with 253 usable IPs. Now, this might look pretty simple at the first glance, but when a lot of people got started into networking, they had the difficulties. And as we will progress with this series, you will understand the power of subnetting and how to structure a network. Even let's say you have a basic router and you don't have a smart switch where you can make use of VLANs, you can still separate and portion your network depending on your needs, right? But that is a video for another time. But I explained before, um, you are going to learn the skills and might not look fun, but it will become fun at some point. And by the end of our journey, you will master subnetting. And I think that's it for today. And stay tuned for part two. Uh, Thanks for watching. If you found this video helpful, give it a thumbs up and consider subscribing for more practical IT tutorials and tools. Don't forget to hit that bell so you never miss an update. And if you want to ask a question or you have a suggestion, drop it on the comments below. I trust me, I read everyone. And until next time, stay smart, stay secure, and keep learning.